Hey everybody, here is your video for section 2.3. It is about adding and subtracting polynomials. So I hope these vocabulary words, if you want to call them that, I hope they're not like totally new and like foreign sounding to you. I mean, you don't have to write this down right here, but like just so you can kind of see on the screen here. Like we've already thrown around words like expression, equation, term, stuff like that. Coefficients of terms and constants and stuff like that. So especially like in the last video, we were throwing around words like that. But let's get down to business here. I think I can just delete that. Okay. So adding and subtracting polynomials. So what the heck is a polynomial? Well, let's dive right in. A monomial is an expression that is a number, a variable, or a product of a number and one or more variables. Okay, I didn't read that very well. But this wordy definition, might not even be like what you sort of wrap your brain around. I mean, a monomial is essentially a term, A monomial is essentially a polynomial that only has like one term. Because mono as a prefix, like just the M-O-N-O part, that means like one, essentially, in like the English language, or maybe many other languages, I don't know. So monomial means like basically one term of a polynomial. And a polynomial is essentially an expression. Like, how there's like mathematical expressions, but then there's like equations, and equations are when you have like an equal sign in there and you have like a left side equal to a right side. An expression is just like an expression. It has no equal sign or anything. And that's essentially what a polynomial is, and a monomial is just when it's only got like one term to it. Okay, so examples like 4x, that's a polynomial, that's an expression, but if it's only got one term, it's a monomial. Negative 3xy squared, that's only one term, it's a product of a number and one or more variables, or it's just a number or it's just a variable. So again, basically like a term, you know what I mean? 7 is technically a monomial. 7 is a polynomial technically, and it's an expression technically, even though it's just a number and that's it. X to the fourth, that's a monomial, it's a single term. Negative 9x to the third power, that's a monomial. Okay, so all of these are pretty good examples of monomials, or polynomials that only have a single term, or an expression that only has a single term. Okay, then the degree, I don't know why I said it like that, degree, the degree of a monomial, is the sum, oh boy, that's an important word right there. Let's underline that because it's important. I clicked on this color, I do believe, yes I did. It's the sum of all the exponents of its variables. So like in this one's tricky because this variable has a power of what? It's sort of invisible, but technically what power does this x have? It has a power of 1. And this y variable has a power of 2. So the overall degree of this monomial would be 3, because like 1 plus 2. This degree would obviously just be 4, this would just be 3, and this would just be 1. How about this one, you brainiacs? Who's got the big brain out there? What is the degree of this? Remember, it's got to be like for the variables. Technically this doesn't really have a variable. Like in a way, you could say this is like x to the 0 power. Ooh, man, I'm getting into things maybe even before I'm supposed to, from topics like down the road. But technically, just saying right now, the degree of this monomial is actually 0. because you could say this is like 7x to the 0. But again, I'm starting to get into things maybe a little prematurely there with, what does the 0 power mean? We'll get to that soon, I suppose. A polynomial is a monomial or the sum or difference of two or more monomials. So yeah, you put again, it could just be a monomial, like I was saying. Just any monomial is also polynomial, or many monomials added together or subtracted or whatever. That's a polynomial. It's an expression. And in fact, I bet what's behind here is the word expression. Yeah. A polynomial that is in standard form has monomials that decrease in degree from left to right. So we kind of put the highest degree first. So if you put a whole expression or a polynomial in standard form, it just goes in order from biggest degree to smallest degree with your terms. The degree of a polynomial is the same as the degree of the monomial with the greatest exponent. All right, so in other words, monomials have their own degree, which we just talked about up here. But there's also an overall degree of the whole polynomial. All right? And that's just going to be the highest power in each term. Okay? So, so this example, you know what I mean? The overall degree of this polynomial would be 1 because that's the highest power, from this leading term, as long as it's in the standard form. This one, the overall degree, even though this degree of this individual term is 0, and individual term right here, the degree is 1, and individually the degree right here of this individual term is 2. The overall polynomial has a degree of 2 because it's the biggest one. And that's how that works. But anyway, whole bunch of stuff here. You might end up having to pause the video at some point if I move on to the next page too fast. But here we go. We're going to have some new vocabulary words here, peoples, so check it out. If the overall degree, here, the overall degree of this polynomial is 0. So we can sort of use the adjective or the label of it's constant. And we talked about this word last lesson. So this is a constant polynomial. And now this one has only one term, so then what's the word if there's only one term? That's right, monomial. We've already talked about that. Okay? So we can call this polynomial, or this monomial, I guess, we can call this term or whatever, we can call it a constant monomial. If the overall degree is 1, like this orange one, we can describe it as linear. So that's a new word. And then how many terms are here? How many terms? There's 2. So if we call something with one term a monomial, we call something with 2, again, it's all polynomials, but we can get a little more specific sometimes. If there's 2 terms, we can call it a binomial. Think of how many wheels on a bicycle. A bicycle, has 2 wheels. So binomial, 2 terms. Now, this one has 3 terms, right? 3 terms. So what do you think? 2 wheels make a bicycle. 3 wheels make a what? Cycle. So like a trident or a tricycle, 3. So 3 terms, trinomial. Now the degree, the overall degree is 2, because look at that power. And we call that quadratic. Again, now we're getting into some words you maybe have never heard in your life with this quadratic. I'm optimistic that you've heard the word trinomial before, and binomial, and monomial, and polynomial. But yeah, quadratic might be, so far, your best chance of never hearing that word ever in your life. And that word goes when you have an overall power of 2. So we can call this polynomial, we can call it a quadratic trinomial based on its degree and how many terms. If the degree is 3, like this guy, then the overall power is 3. If the overall degree is 4, then it can be something like this. Overall degree is 4. If the degree is 5, something like that. If the degree is 6, something like that, where like the highest power is 6 and the highest power here is 5, so on and so forth. And by the way, these are all written in standard form because they go from like the highest power down to the lowest power. Highest power down to the lowest. Highest power down to the lowest. Okay? That's what standard form is again. Okay? So how many terms does this have? How many terms? Only one, which makes it a what? Monomial. How many terms are in this purple one? 2, which makes it a binomial, like 2 wheels on a bicycle. How many terms are in this baby blue one? How many terms? That's right, there's 4. So what do we call that? Well, there's not actually a fancy name, so we just got to use polynomial, And if there was 5 terms, it's just a polynomial. Just like all of these are technically polynomials, but we can get a little more specific when there's only 1, 2, or 3 terms. How many? Whoa, sorry about that. How many terms here? 3, which makes it a trinomial. Now here, there might be some new words here. How can we describe it that, based on the fact that it's got a overall degree of 3? Well, we call it cubic. This is a cubic, like cubed, It's cubic, and then this we can actually call quartic. Once again, now we're getting into some kind of weird vocabulary. And we can actually call this quintic. So, this purple polynomial, we can call it a quartic binomial. This baby blue one, we can call it a quintic polynomial of 4 terms. And then 6, now we've kind of run out of fancy words, at least the ones that are sort of commonly used. So we're only going to go so far with this. So constant. So when it comes to degree, we got constant, then linear, then quadratic, then cubic, then quartic, then quintic, and that's as far as we're basically going to go. And then as far as number of terms, we have a monomial, and then binomial, and then trinomial, and then we just got to say okay, it's just a polynomial. Again, keep that paused if you still need to write that stuff down. And then some examples, okay, where we actually get into what if we were to add 2 polynomials together? Now, if I was going to be a little more specific, I could call this a trinomial that we're adding with this other trinomial, right? And I can get even a little more specific if I needed to. This is a trinomial that's quadratic. Same with this guy. It's a trinomial that has an overall power of 2, so it's quadratic. Anyway, let's really get down to business. So, obviously you can't help but notice that there's these parentheses, because technically it's this polynomial, as its own thing in parentheses, plus this other polynomial, it's its own thing. So it's in parentheses. And so in general, how do we clear parentheses? Well, last lesson, I think, we talked about the distributive property, right? How, again, you don't need to write this down, but if we had whoa, kind of light on the font there. Oh God, mouse skills. I don't like that one bit. Again, you don't need to write this down, this part here. But here, when you have something being multiplied to a bubble of terms, you have to distribute that in order to kind of simplify this and clear the parentheses. So here, you can look at this as the same thing, but what number is technically out in front here? What number? It's invisible, but what number is out here? Isn't it just a 1? And then what number is technically out in front of this set of, like this trinomial in parentheses? That's right, again, it's like positive 1. So if you want to actually go through the motions of like distributing a positive 1 and actually doing 1 times 4x squared, 1 times 6x, 1 times 7, and then this, like here, 1 times 2x squared, 1 times negative 9x, 1 times 1. I guess you could go through those motions, but essentially you don't even like need these parentheses, you know, because you're just like distributing a positive 1 in both of these bubbles. The parentheses they don't really even matter that much, like at all. So what this is going to amount to is just combining the terms that you can actually combine, you know, like terms. So this term and this term are like terms. They have the same x squared variable part to it. So this term and then this term can combine. And then we have a positive 6x and a negative 9x. Now listen, I'm going to say that again because I can't stress this enough. This is not just a 9x. It's a negative 9x. The sign in front of the term is a part of the term. You know, it's a part of it. So it's a positive 6x and a negative 9x that are going to combine because they both have just an x variable to it. X variable part to it. And then the positive 7 and the positive 1 are able to be combined. And, oh God, you don't need to write this part out. I mean, don't even bother writing this out. I just said this. What this is basically doing is like glorifying the, I guess might be like the associative property, and maybe the commutative property a little bit. Like you can like rearrange all the stuff because of those. Remember that? Commutative property, associative property. But don't even write that down. Bottom line is, you know, this term is going to combine with this term to make 6x squared. Again, positive 6x and negative 9x. That's negative 3x. Okay? Think about it. And then 7 and 1 make 8. And yes, this is in standard form, which is probably the way you want to go with like your final answers. Like as a general rule, you want them to be in like standard form, okay? Again, pause that if you need more time, but I'm going to move on to this problem where we're getting a little bit more crazy. Once again, now, well, we're subtracting polynomials, so once again, we're like grouping this trinomial together. This time it's cubic. And then we're grouping this trinomial together like as separate polynomials because we're subtracting them from each other. But all this is really going to amount to is, you know, what's going to be distributed through these terms, like what's out in front. A positive 1, technically, but, here we go, what's technically out in front here of this bubble? A negative 1, okay, people? Now, when a negative 1 or a negative sign gets distributed, that will change these terms, you know? This is going to become a negative x cubed. This is going to become a plus 8x squared. And this is going to become a minus 11. See that? These terms didn't change because it's really just like a positive 1 technically. But this became minus x cubed, or x to the third, plus 8x squared, and then minus 11. A lot of people mess this up, even like honors students, whatever that means. And I'm pretty sure we can just kind of skip ahead to this. I don't even think we got to worry about that. Because all that's doing is like, okay, this term is an x to the third power term, and then this term, so these two terms can combine because they are like terms. These two terms can combine because they're like terms. But then this guy, nothing will combine with it. You know, negative 3x will just stay, like there's nothing to combine with it. Same with this minus 11, nothing, so we just kind of have it down here in the final answer, which once again, that is in standard form, so that's probably the best way to present your final answer. So once again, only add the terms that are able to be added together. Don't force anything. you know. And again, pause that if you needed more time. But here we go. Nothing that new here, like nothing really new about this example, but here we're going to have to like, watch this is kind of cool, distributing the 3 to all those terms, and then like distributing this -1 to all those terms. You might want to actually write out like this little sort of visual here, bam, kabam. And so clearing the parentheses gets us there. 3 times x squared is just 3x squared. I mean, that's all you can really do, And then 3 times -2x. Well, you can do the 3 times the -2 to get -6, and then like times the x, And then 3 times +1 is, +3. And then -4x squared, and then this minus becomes a plus because of, that. And then now we look to only combine the terms that are like terms, like this guy and this -4x squared. So what's 3x squared and then -4x squared make? That's right. -1x squared, which is really just like -x squared. You don't need to write the 1, even though that's technically what this is. -1x squared. And then this -6x, will that combine with anything? Now again, at least mentally, you have to kind of keep in mind, like, what you've already taken care of. So how about this term? Will this combine with anything? This -6x, it's not just 6x, it's -6x. Yeah. This other, so -6x plus 3x, that makes -3x. And then obviously this term, there's obviously nothing for this to combine with, and so it's bring it on down with the +3. All right, which of course is in standard form. And so that's all there is for me to say right now about adding and subtracting polynomials together. So again, it's either a matter of like, hey, you're either distributing like a minus sign or a -1, or you're really not really distributing much of anything, and you just drop the parentheses here. And then the other thing we did in this lesson was all this stuff with all these vocabulary words, all based on the degree and based on the number of terms. So let me know if you have any questions as you do your homework. Okay.